All right, in this video, we're going to talk about integration by substitution. And just to kind of give you an idea, if we're thinking about like ranking the most important things we've covered, the probably most important thing we cover all year is like the fundamental theorem of calculus. It has the word fundamental in it. It's really important. Step 2, probably the chain rule, because every single time you want to take a derivative, you're thinking about the chain rule. And step 3, most important thing, would be integration by substitution. So this is one of the really important things to kind of understand and be able to do consistently, because it's going to really have an effect over the rest of the class and how successful you can be. All right, so we now learn the importance of being able to undo the derivative process, because that helps us find the exact area under a curve. And we covered how to undo the power rule. And when we were doing derivatives, we learned the product and quotient rule. That's something you don't learn until calculus BC, about how to undo the product and quotient rule. However, in AB, the class we're in, you can learn how to undo the chain rule. So what is the chain rule, just as a reminder? The chain rule looks like this. I'm taking the derivative of a composition of functions. I take the derivative of the outside, but I keep the inside the exact same. And then I take the derivative, I chain the derivative of the inside afterwards. How could we possibly undo this complicated process of the chain rule and kind of undo this antiderivative process? Here is the substitution strategy. I'm not going to read the whole thing because you can pause the video and just kind of write it down. But go ahead and write this down, and we'll kind of see it useful and used in a example. All right, so when we're doing substitution, we're looking at something where the chain rule happened. So if there's something where the chain rule happened, we have something that stayed the same on the inside, and its derivative is on the outside. And what we're going to do is we're going to look for this thing that was on the inside, and we're going to call that u. All right, so we're kind of looking for parentheses, something inside of something else, and that's going to be our u. So here we're going to make u equal to the thing inside the parentheses, 3x squared plus 4. All right, now here's the kind of strange process with this substitution algorithm. Is our whole goal is to undo the derivative process, but actually in this step, we're actually going to do a derivative. So if we do the derivative of u, we just get du. If we take the derivative of 3x squared plus 4, we're going to get 6x dx. Right, the derivative of this thing, but we took the derivative of an x, so we have dx. Now we want to solve this equation for dx. So in this case, it's fairly simple. We just divide both sides by 6x. All right, so du over 6x equals dx. All right, so now what can we do? All right, well, we have 3x squared plus 4. That's just going to be u. And we have something that dx is equal to. All right, so now I'm going to rewrite my expression. Nothing's happened with this 6x yet. But this, instead of this whole thing raised to the 4th, is now u to the 4th. And dx, instead of being dx, is du over 6x. Now, if you've done your substitution correctly, now we're trying to take the derivative of something with a u. There can't be any other variables, so the x's should go away. In this case, we're lucky, quote unquote lucky. It's because we did the right thing. The 6x's cancel. So this is the same as the integral of u to the 4th du. All right, so by doing this substitution, by replacing 3x squared plus 4 with this u and changing our thing we care about, we get a much simpler antiderivative, and now we add 1 to the exponent and divide by the new exponent. But our original question was about x, not u, so now we remember, well, u is actually that. And that is our final answer. All right, so this is the process of substitution. It's really formulaic. You just do the same thing every single time, and make sure you're writing down all these steps. All right, students try to skip kind of these 2 steps and kind of guess as they go about like what the dx is going to be and all that. All right, don't do that. Actually write down every single step. I know we'll see this in future examples. All right, sometimes you get this extra number at the front here, and if you don't write down every step, there's no chance of you getting that number correct. All right, so here's another one. Again, for all of these, luckily it's a video. You can always pause and think about what is u going to be. The first thing you should actually do is, can you do this without u substitution? There's no way you could take the antiderivative of this itself, because these 2 things are being multiplied, and we don't know how to take the derivative of things being multiplied. But u is always inside of something else. So right now we have this square root with something inside of it. U is x squared minus 5. We take the derivatives of this, and again, this is the confusing part because we're doing derivatives to eventually do an antiderivative, but we take the derivatives of this, du is 2x dx, and we solve for dx, so we replace it in our equation. Like that. All right, we haven't done anything with a single x out here, but this x squared minus 5 is u, and dx is du over 2x. Again, if you've done your substitution right, the x's should go away, and you only have u's left. All right, in this case, we still have this 2 on the bottom, so we can't forget that kind of 1/2. And that's what I was talking about in the previous one. If you didn't write all these steps, you might miss this 1/2, thinking just everything cancels, because it doesn't always cancel. All right, now we can have a much simpler antiderivative. I remember u is u to the 1/2, and this is the 1/2 is just going to stay. U to the 1/2 turns into u to the 3/2 divided by 3/2. All right, and that's the same as multiplying by the reciprocal. And those 2's are going to cancel. Oops, I forgot the plus c here. And now that I simplified a bit with the simple u, I can go back and remember what u actually was. U is x squared minus 5. Again, a little complicated, but it's the same steps every single time. All right, so throwing you to the deep end early, go ahead and try this one. All right, again, write out every single step. I can't stress enough how important it is to write out all these steps with u, du, dx, plugging things in and canceling stuff out. If you don't do that, you're definitely going to mess up the final answer, even if it's only by a constant. That's very important for the multiple choice section of the AP exam. All right, so go ahead and try this one, and I'll show you the answer in 3, 2, 1. And here's the solution I came up with. So our u is inside the parentheses. And we do our whole taking derivatives and solving for dx. We get a little lucky in this one because the entire 3x squared cancels out. Makes it a little bit simpler. Do our antiderivative for u. And remember, u is actually just a placeholder for this whole thing. All right, so that's integration by substitution. All right. I said it a few times pretty much in every example. All right, but the most common mistake students make is not writing out each of the steps that we covered in this video. All right, so make sure you're declaring what u is equal to. Make sure you're doing your du when you're solving for dx. You're plugging everything in, doing your antiderivatives, plugging x back in. All right, every single one of those steps, write out every single time. All right, so here are the important things. All right, we can undo the chain rule by integrating with substitution. All right, remember to write down each step along the way. And at the very end, remember our original question was about x, so actually replace u with the original expression in your final answer.